Welcome. Let's look at this particular question on vectors. The question reads, in the diagram below, vector OP equals to 2 vector P, vector OQ equals to 4 vector Q, and the ratio of the two lines PX to XQ are 1 to 2. Observe. Very important information that we have here. So the ratio of the line PQ, observe. So in the diagram, we're able to see that this line PQ is actually in ratios of PX to XQ, and we're told it's 1 to 2. So meaning the units, the distance from P to X is 1 unit. So this is 1, observe, and the distance from X to Q is 2, observe, and this will be 2. That's the idea, okay, of the entire line PQ here. Very important, right? Now let's get started and see how we answer these questions. We're asked to express in terms of vector P and or vector Q. Express in terms of vector P and or vector Q. So number 1, vector PQ. How do we get at Q from P? Okay, at Q from P. Remember to use the movements that are known. For example, to arrive at Q, we're going to move from P to O, from O to Q. But remember, it's important to take note of the direction of the arrows. If you're moving against the arrow, you're going to negate this particular vector, and it will be -2 vector P. But where you have a positive direction of the arrow, you're moving positively the arrow, no need of negating. We're just going to have the positive 4 vector Q. Okay, let's get started. Vector PQ will be given as vector PO plus vector OP, rather vector OQ. Okay, so the expression will be like this. Vector PQ equals to vector PO plus vector OQ, right? And let's try to substitute and put the respective vectors. So vector PO, we see that we are moving negatively vector OP. Okay, so vector PO, we are actually moving against vector OP. Observe. But vector OQ, we are moving actually positively the arrow, this particular vector, so it's okay. You see? Let's now introduce the substitution. So where we have the vector OP, we're going to put 2 vector P, right? So say -2 vector P plus vector OQ. We see here that it is 4 vector Q. And this becomes your answer. But you can hygienically write this particular answer as 4 vector Q minus 2 vector P as our solution. Part B, it requires us to find vector PX. Vector PX, let's check vector PX. So from P to X, how do we move? Remember, PX is in the ratio 1 out of the entire line. That will be 1 plus a 2, which is 3. So it will be 1/3 of the line PQ. Okay, that's the expression. So vector PX will be written as is in the ratios of PX. Okay, PX out of the entire line PQ of vector. This is vector PQ. That is in terms of the ratios. Okay, that's how you write this one. Now observe, these are ratios here. Px, we are taught to say Px is actually 1 and xq is 2, meaning PQ is 1 plus 2, which is 3. So Px, observe, from P to X, that is 1. So I'm going to write 1 here. Out of PQ, we know it is 1 plus 2, which is a 3, of the vector PQ. Vector PQ is actually what we've just found. So we plug in here for vector Q, okay, minus 2 vector P. We close and simplify this. When we simplify, we're going to have 4/3 vector Q minus 2/3 vector P. And this is our solution. Simple, right? Let's move on to the third question. The third one, we're asked to find vector OX. How do we get at X from O? We wouldn't want to move using this way, though it's correct, but I would want to move using the obvious movement. By obvious movements, I mean our movement have to be well defined. For example, if you move from O to X, we can move vector OP plus vector PX. We know that this line is well defined as 2 vector P, and this line is well defined as well because vector PX is actually what we have just from finding. It's right there. So let us move let's use well-defined movements. That's what it means. Now let's get started. So vector OX will be vector OP plus vector PX, where vector OP we know as 2 vector P, whereas vector PX is actually what we've just found. And we're just going to bring this down. This will be 4, observe, 4/3 vector Q minus 2/3 vector P. From here you simplify. We have the P, we still have the P here. So if you simplify these two, we're going to have something like this. We're going to have 2 vector P minus 2/3 vector P plus 4/3 vector Q. When you simplify this, we're going to have these two fractions, expressing them as a single fraction. We're going to have the LCM between 1 and 3, that's a 3. 1 into 3 is a 3 times 2, that is 6 vector P. Observe, this is 6 vector P. Minus 3 into 3 is 1. 1 by 2, that is 2 vector P. Observe. We go further. We say plus 4/3 vector Q, right? At the end of the day, we're going to have something like this. 6P minus 2P, that is 4/3 vector P plus 4/3 vector Q. And this is our solution. Simple, right? So the key is the expression and knowing the movements. Very important. Let's move on to the last question. Let's look at the last question. It says, given that vector OC equals to H vector OX, show that vector CQ equals to 4 open 1 minus H over 3 vector Q minus 4H over 3 vector P. So we're going to show. The answer is already here. We're just showing how they arrived at this particular vector using this very important point. Okay, we use this information as much as possible. So remember, we are moving from C to Q. Now before you do move from C to Q, it's important to know what vector OC is, the one guided in the question. So we're given vector OC as equals to H vector OX. Now it's important to know what vector OC is, but we know to say vector OC is H vector OX. But vector OX is actually what we've just found here. Observe. Vector OX is 4/3 vector P plus 4/3 vector Q. So we're going to write it here. So we substitute and put it in the parentheses. We're going to have 4/3 vector P plus 4/3 vector Q. From here we simplify. We're going to have 4H over 3 vector P plus 4H over 3 vector Q. Once this is done, we now know what vector OC is, right? That's what you do. Remember, a vector is written at the end always. Now we now want to show that vector CQ is actually this expression here. Now it's the question of asking ourselves to say, how do we get at Q from C? How do we get at Q from C? How? So we're going to move CO, because we now know this line is well defined as vector OC. So we're going to say vector CQ is equal to vector CO plus vector OQ. Okay, that's the movement. So first of all, write the expression. So this will be vector CO plus vector OQ. Once this is done, it's the matter of now substituting. Vector CO, we see that we are moving opposite vector OC, but vector OC we know is this expression that we've just written here. So I'm just going to negate vector. We're going to negate vector OC, observe, plus vector OQ here. So when you substitute, we're going to have negative, you put in the parentheses here, we're going to have 4H, observe, over 3 vector P plus, we're going to have 4H over 3 vector Q. Then we close the parentheses. From here, we're going to simplify. Negative times that, we're going to have minus 4H over 3 vector P plus, we're going to have, sorry, not plus, but to say negative times positive is negative. So we're going to have negative 4H over 3 vector what? Q. At this particular point in time, we are going to substitute. Okay, we are going to substitute. But we also know that this particular vector here, which you're seeing, okay, this vector here is actually negative vector OC. So we need to add on to vector OQ, which happens to be 4 vector Q. So at the end of the day, if you wanted here, you could have just added plus 4 vector Q. Let's also add plus 4 vector what? Q, because that is vector OQ. Okay, from here, we're going to simplify this, right? So when you simplify this, you're going to appreciate that we're going to have something, right? So what you do, we're going to simplify, we're going to group like terms first. Now from the look of things, we see that this particular expression here that we're showing, okay, the vector Q is starting and the vector P is ending. So I've got two terms. One term has vector Q and the other term has vector P. So we're going to write this particular expression in such a way that the vector Q starts, okay, and the vector P ends. So in this case, vector Q we know is this side here. Okay, so what we are going to do is to do this. Observe and observe carefully. So if we group like terms such that vector Q vector Q are starting, these two vectors, if they are starting and they're grouped together as they are already here, we're going to start with them and end with vector P. Take note. And this expression will be like this. Okay? That's how the expression will actually be. At this particular point in time, we are going to factorize. We're going to factorize this. Okay? When you factorize this, we're going to, to check out what is common. In this case, what is common? We have 4 vector Q. So let's check out 4 and vector Q. Now you note that 4, the number 4 is a scalar, and the scalar is written first. So we write the scalar, which is 4, then you open the parenthesis. Remember what is, when you divide 4, we do this here. So we're going to write the number 4, then you also close the parenthesis there. Remember what you're taking out? We're taking out 4 and a Q, but 4 is written first here. Then the Q as the vector will be written at the end. So when you divide the 4Q into 4Q, it is just 1 minus 4Q into this, the 4 and the Q cancel out, and we are simply going to have H over 3. Then you bring down the minus 4H over 3 vector P. Once this is done, you can say hence shown. And this is the solution. Thank you for watching. Please remember to like my videos, subscribe to them, and so that each time I post a video, you're notified. Thank you for your time.